Good day, distinguished academics. My name is Gabriel Jr. and I'm presenting on behalf of the team that worked on this topic, Photovoltaic Systems and Technology Failure in Ghana, Experience from Technical Stakeholders. For many of us who have been following the news in recent times, will observe that there has been a global concern against climate change and global warming. And this concern is leading to policies that is shifting the attention from fossil fuels to more cleaner and renewable forms of energy. Now, if you look at the renewable energy sources, the literature is very clear. You will find solar PV technology, what we call the PV systems, as the fastest growing technology within the renewables, and in fact it is the most promising. And so governments and institutions are making policies and programs to support the deployment of this technology, and most of them are focusing on sub-Saharan Africa and other developing countries in order to meet up with the sustainable development goals. Already several projects have already been commissioned and are in use both for private and government-owned projects. In fact, individuals are actually making efforts to install these systems within their households, and they have been documented in different reports. The problem, however, is that we find out that most of these projects are not performing well. Some of them are completely shut down and they have been abandoned entirely. And this is creating a lot of problems because people are developing a negative attitude towards the PV technology. And so what our research sought to do was to identify the challenges surrounding the PV operations and the possible causes of failure within the sub-region, with Ghana as our focus. Primarily, we sought to answer the question, why do PV systems fail in Ghana? And so this is how we went about the work. Like I said earlier on, the study area was Ghana, which is in West Africa, and then we used primarily questionnaires and interviews. Our focus was on technical stakeholders, and so we're looking at people who have been in the system. And when I talk about technical stakeholders, I mean the engineers, the project managers, people who are in academia, technicians. And so those are the people we focused on. So we asked them series of questions through questionnaires and followed up with interviews to find out the real reason and the real causes of these systems failure. Of course, we focused on also, as you will see later on within our results, what components within the entire system often leads to failure, so that by identifying it we will know how to deal with the problems later on. And so we used these statistical softwares, SPSS and Microsoft Excel for analysis. We did, because of the nature of our data, we did both qualitative and quantitative analysis, more of a descriptive analysis on the work. We were able to engage 47 people in the study, and if you see the distribution, 83% were males while 17% were females. Now, on the level of education of respondents, the graph here indicates that all our respondents had formal education. And then here we find the classes of respondents within the PV industry, so the various portfolios they hold, our respondents hold. Then finally, which is of course very important, the years of experience of our respondents within the PV industry. You will find that most of them really have a reasonable number of years of experience within the industry, which is of course useful. Now we try to find out how our respondents acquire their components when there is the need to start a project. And you find from the graph here, majority rely on the local market, even though some others combine different options, as you can see from the graph. The local market is mainly imported goods into the country. It doesn't mean that these are products made in the country. They are products that are imported from the country, and it is because the country Ghana doesn't have the capacity to produce all these components on a large scale so that our respondents can fall on during project implementation. So we try to find out in an ideal situation, given all the reasonable circumstances, when there is the need to go for components, what are the factors that influence our respondents' choice of components? This is a Likert scale that we use in our analysis for the computations. And for example, if we take the PV module as a component of the entire system, you will see these are the factors that we considered: availability, cost, quality, and customer preference. And so taking PV as an example, you'll find that majority of our respondents, using the line graph here, considers quality as the most critical and reasonable factor to consider in making a choice. Let me stress on this. This is the ideal factor they would consider in making their choices. If you go down here, you find the other major components and the factors that actually influences. You will see that there is a shift here. Availability is very critical when it comes to inverters. The batteries and all the other components are also presented here. The line graph is what gives the overall for each component. Now when we come to this graph, we give for the entire system, based on the analysis for each component, what are the factors that majorly influences the choices, and you would see that quality leads for all the components combined. Finding the average, quality leads, followed by cost. This is of course reasonable. Everyone going into a project would want to focus on quality. The reason why we did this was because in the literature we identified that yes, even though people claim to go for quality, it was actually revealed that other factors most of the times influence the ideal factors that project implementers normally would want to use. So for instance, in China there was a study there, and it was realized that customers actually go for price reduction rather than quality, as they claimed initially. And so we wanted to find out, in the case of Ghana, are they able to go with the ideal conditions, or some factors influence these ideal conditions that they have set? So we actually found out within the interviews that there is often a compromise on quality of components used. And the reason is because the customers come with certain preferences, not that they want cheap products, but because that is what they can afford. And so oftentimes there is a compromise on quality and a compromise on a lot of technical considerations, just so that the customer can be satisfied. Sadly enough, in most cases, it's either the technicians, as they communicated with us, it's either the technicians go with the customer's budget or they lose the contract. And it is interesting because the market is also made up of a lot of components that are already designed based on customer budget. So any amount you have, you go into the market, you can get something that can suit what you really want. And so if you see the graph that is presented here, this is a dummy graph that shows the ideal situation in the dotted graph. The red line, that is the ideal. So you find the ideally everybody would want to go for quality, but in reality, in the case of Ghana, you see that there is a shift from the quality to customer preference. That means customers have power when it comes to deciding what to use, and because they don't have any technical knowledge, they often compromise on quality, and because of that, systems are liable to fail at one point or another. In most cases, projects are abandoned not because the entire system has collapsed, but because just a single component is at fault, and inability to identify these problems often leads to the abandonment of the project. And so we try to find out, in the case of Ghana, which of the components is often prone to failure, so that when technicians want to troubleshoot, at least they know how to go about it. And so the table here shows the summary of it. You will find that inverters lead about 32% of faults come from inverter, which is the highest, followed by batteries, and so on. Now, what are some of the factors that causes components failure within the system? And our respondents helped us both in the questionnaire and then in the interviews. You have the graph here that shows normally low quality products is a cause of component failure, and it's obvious because we have seen earlier on in the presentation how the customers rely on imported goods. We have also seen how most of the time during the project implementation, quality is often compromised, and so it is not surprising that low quality products can be the leading cause of components failure. Also, the identify user error, that goes back to customers not understanding how to handle the PV systems, and so they handle it carelessly, and oftentimes it leads to failure. In the interview, some of them shared the experience of how some customers actually connected a 2 kilowatt refrigerator to a 1 kilowatt solar inverter, and when the system went off, he was complaining that the system has failed. So we have a lot of other experiences that people shared within the interviews. Now, another aspect is the sizing and installation errors that goes back to the technicians themselves. In most cases, we found, and they revealed to us, there are a lot of people within the industry who are not licensed or even unqualified to do installations. Some electricians feel that because they're electricians, they can go into solar PV installation, and they just do it without proper training. Some renewable energy engineers also are not so good when it comes to wiring, so they just go in and then they are not able to do the wiring well, and so this gap between the various sectors that are supposed to be bridged to bring quality is often lacking. So in conclusion, we observe that customer preference often leads to compromise on quality as a result of the cost to be borne by customers. Again, we also saw that inverters are the components within the PV system that is often prone to failure. Then the highest cause of component failure within the system was identified as low product quality. Of course, other factors that we identified are also critical and must be looked at. So in summary, we seek to say that the information that this research provides will be relevant to stakeholders who seek to enter the PV market in the sub-region, especially in Ghana, and it will also help shape the perception of policymakers in the country as they seek to identify and deal with the problems surrounding the PV technology deployment and the systems. These are some references that we have here. Thank you very much for listening.